All right, last day. It's the finale.
Captain Log, last day.
Last mile.
Finally the last day.
Yeah, it was kind of intense, a pretty intense week, like a lot of input. But
I'm actually like kind of thinking I'm kind of like exhausted like with this a lot of focus. So yeah, I mean like there is still like so many different things that I would like to check out.
I know.
But I don't want to do it like next week, let's say.
Yeah,
I want to do something normal.
I agree.
I agree.
I feel the same way. I feel
yes,
the same way.
Yes.
At some point, it's just there's so much information at some point, and then I personally get into this situation where I don't even know what to look at anymore. If there's just too many things.
Yeah, exactly.
And you know, there's always more we can look at. I think that's okay. I mean, I think we can, you know, then next week actually focus on trying to make some improvements. I also feel personally, I always want to get something tangible out of it at the end of the day. And if you just collect data for such a long time, it doesn't always feel super satisfying, right? Because it just often just raises more questions than those you already had. And yeah. Okay, so, but yeah, sorry, go ahead.
So I guess like it can run on 2 gig already. Like I think that this
You're
is
optimistic? You're optimistic?
I mean like I'm certain like
okay,
even like with these changes like with the Puma single, some other random improvements, Nakayashi fork, maybe I mean in Puma single we don't really need it. I mean Nakayashi fork is still useful. GT parameters, maybe like tuning some of these services, like it can run like on 2 gig. Really, like. I mean, and like we can really figure out like the architecture sizing for like running on the 2 gig. So it seems possible, and it's kind of like seems that there are so many different aspects that we can still improve to have even more headroom on this 2 gig.
Yeah. I talked a lot about this a bit with Craig in the one-on-one yesterday, and like I don't know how you feel about it, you two, but my feeling is because we looked at very different things, right? Which is great. I love that we looked at so many different things, and some of them were more taking an angle of is there like something we can do less of, right? You know, like start fewer services or something, but then also out of the things we need to do, how much memory do they consume, and can we, you know, improve that? But it seems to me like it sounds like the lowest hanging fruit are actually also the simplest things we can do, right? Which is just like doing less, right? Like maybe not always running Grafana by default, or not always running, you know, doing this or that by default. And that's just really simple to do because Omnibus has really good support at actually looking like during installation, actually making decisions based on, you know, available node memory, the number of cores we have available. We already do that for sizing the Puma worker pool, right? And other things. We do it for the image scaler as well. So we actually have all the infrastructure in place to make these decisions. And it should be fairly simple to do something like, you know, if you're running on a node restricted to 2 gigs, you know, just don't like start X, Y, and Z by default. And maybe we can give the admin a heads up like, hey, we disabled these features, but if you do want to run them, you have to enable them explicitly, but it will cost you, you know, that and that much in terms of memory. It's maybe a product decision, but
I'm kind of like thinking the same, that like to run the like initially on the 2 gig, we probably are fine with even like fixing this Puma single, which seems to give like a lot of like uplift in the memory usage, disabling some services, tuning some parameters of the omnibus basically, which is like, let's say like this, we disable Grafana or like these other services that we may not need. But also like tuning these GC params for maybe for these other services. So I guess like this could be really like the lowest hanging fruit that we can do to have like much better memory usage in these circumstances. And I'm kind of like thinking that probably like my biggest takeaway from that week is like we need to tune the services and the parameters of these services, because we are not doing that. We are running in the default really. And like at least I think like we have this discussion about the worker killer, Puma worker killer, which like says we should leave we should increase the memory limit. But I'm now thinking that like to address that, we should tune GC params basically, not leave the memory limit. So like play with different settings, check if we can actually tune the GC settings to be more aggressive, but still like have decent performance. And this is kind of like keep this memory more in the place. So
you mean like per reference architecture, have like look at different GC settings?
I think like figuring out like the our settings for running GitLab because of the how GitLab is structured, how much memory it allocates ahead of the time, and things like that. So it's very likely that in the 2G some of these config options would be slightly more aggressive, but I think in general, like we need to have different settings than the defaults. The default just doesn't work in our case, which kind of results in this like constantly growing memory usage over time. So I think this is really like my perception, like which is kind of like very aligned with yours, like that there is like a few probably easy low-hanging fruits that we can do to actually to achieve this 2 gig and actually decrease the memory usage of GitHub.
Yeah, I also feel like the GC is only one part of the equation, right? Because we also have the allocator that will have an impact on fragmentation and memory growth. So what I have not looked at all, this is like super low-level stuff, and it would take me a while to understand that. But like what we think could look at as well is how we could tune JE-malloc differently for differently sized deployments, because it has tunable parameters for things like the number of memory arenas it keeps, and there's a trade-off between the number of arenas and the number of concurrency, the level of concurrency you want to support. So that's not something we really have looked at yet, right?
Yes, but I think like it's like this recipe is really like pretty general. Like we talk mostly about the GitLab rates right now.
Yeah.
But we have so many other services running as part of the Omnibus that we should tune as well.
Yeah. Honestly, we didn't even look at Sidekick, right? Or I did not even look at Sidekick at all. I was so busy looking at just Puma stuff that and there's probably different things we can do about Sidekick.
Yes, and I think there is so many like Sidekey. I mean, Sidekey probably is pretty similar.
Yeah.
But I guess it's still like connected with like my general like even looking at your heap usage and looking at the loaded features, amount of the file that we load. Like we do a lot of bad stuff basically of like loading everything always, like 14,000 files. It's ridiculous just to serve the request.
Yeah.
Like it's ridiculous that like we load everything into memory, and like it takes a long time to load, and also it takes memory space. So I guess like it's kind of like something that we didn't investigate very deeply, like how we can selectively load, because like I think if we could be more selective, it could actually give us a lot of space basically. I mean, this GraphQL that we discussed yesterday, I don't think that we kind of proceed with that further, right?
We didn't.
No, but I think that's okay. I mean, I think it's okay if we just identify stuff this week, and then starting next week, we can actually create issues for fixing that stuff, right? And I think, and GraphQL was one of these things that came out. Rouge was something I looked at yesterday, super briefly only, but I think it's a Markdown or like a code highlighter or something like that. We use it for Markdown. We don't need to load this for the API or something, right? If for our API fleet, we don't need syntax highlighting.
Exactly. So like for the Sidekick, like we don't need probably to load like a number of the code that we are loading.
Yeah.
And also,
should we maybe focus to find a way how to selectively load and not to concentrate, for example, for the exact gem?
That's a good point.
Yeah, because I am not sure how we can achieve that. And I think it's not a problem in the end to implement that to load, for example, GraphQL for Puma, but not for Sidekick because we don't.
I totally agree with this. I would love to
But
talk about
I
that
have
as
no
well.
idea how to
Yeah.
selectively
Because
load
I would prefer, because I think our code base or our boot path is already a bit messy in the sense that it's full of these kind of if defs, or like, you know, if this or this runtime, you know, or this and that feature enabled or whatever, we go down these separate code paths and it's really difficult to wrap your head around. I think maybe at this point we should really think about maybe our team should look at a solution that we can put in place to actually load different kinds of bundles of code dynamically, but in a structured way, right? So that we don't have these like 20 different branches that are like kind of scattered throughout our initializer.
Yes,
files.
and I was thinking about something that maybe what we should kind of do is like, as part of the paths, like define different contexts. And like, let's say that you have like the shell context that is loaded always, but like you have the context which is like, I don't know, the folder side key. Like what you have like folder web API side key,
yeah,
basically, and like you have the specific code for these features in this folder, basically, that it's only loaded in this context, but not in the other contexts. So kind of like, because like I think one aspect is like identifying how to load, but the second aspect is like having the pattern that makes everyone to say, I want to add this class into sideKey. So I'm just gonna add that into that folder, and this is only gonna be loaded in the sideKey, and kind of have our test suite also adhere like to this. So I guess like the common part would really be all models, maybe majority of the lib, but there would be a lot of uncommon parts that like side key workers, probably even like most of the services would be only loaded in the side key context, really, right? And not really in the Puma context, but Puma would load the controllers that side key would not load. So I guess like we don't really have this split, and like it's kind of like evident with the side key cluster and this kind of messy situation that like we have command helper that is using a very specific, but it's still like preloaded in other cases. So like our code structure is like, it's not selective because of the structure, how it's like the work tree is structured.
Yeah, and I just want to also for anyone who watches this recording, just one example of this, because I just recently looked at this and I got really confused. So this is our Prometheus initializer. It's crazy, really. It's so hard to understand what's going on because also this is not even, it will not go down different branches, like here, for instance. So like there's like all these different dimensions, right? Because you have, first we have these checks, are you a web server? So are you Puma basically? But Puma can run in different modes, right? Puma could be action cable, right? Or it could be like a normal web node, or also on .com it could even be a Puma worker, but maybe it's only serving API traffic, right? So that's yet another kind of workload. Then we have okay, the EE switches we have anyway, but then yeah, Sidekick might do something totally different. Yeah, then we have environments, right? So are you in a production environment or not? And another one, which is if you are a web server, are you running in clustered mode or not? Because then sometimes we delay things to run in worker or like Puma forking callbacks, right? Otherwise we run them immediately. And it was really hard to just look at this and understand like what is going on in any of these cases. I thought like this file was a good example because it's not very long, right? It's not that long, but
yes, but
all
like,
of these possible cases are concentrated in this one file.
Yes, but like actually have all cases here, like reflected basically.
Yeah, I mean, this is an extreme example, like, and I'm not saying this is everywhere like that, but I thought it was a good example to just show the complexity that we're dealing with here. And it will be difficult to untangle all this stuff because it's just not two different cases or whatever that we need to distinguish. It's all these nested kind of multi-dimensional cases where there are multiple cases per dimension, basically, that can be true in certain combinations. So maybe we could start even by having like some kind of matrix that where we write down which cases are even possible. You know, for instance, like Sidekick and action cable cannot be true at the same time, right? So like so some of these cases are mutually exclusive, but not all of them are. And I can't even say I understand all of them at this point. So for me, that would be a good start to even like see what are the possible things that can go on here.
I'm kind of thinking like, is it time like to remove unicorn?
Yeah, that's a good point to simplify that a bit. Yeah.
It's like, because like we have this unicorn
Yeah.
tag, and like I'm not sure if maybe there are some customers using that, but like we are pretty far into 13. So maybe
Yeah,
like the
good
first
point,
step is like remove unicorn.
Also, yeah, and
To
like,
reduce complexity, yes.
we can look at it separate. We have stats for self-managed from the topology ping, right? Where we track how many customers use Puma versus Unicorn. I do remember just from looking at it like a month ago or so that the vast majority are using Puma already, but there are still Unicorn users. And
Yeah,
the thing is though, like those users are, it will probably take like the way I see it is how this usually unfolds is that is a large chunk of users that upgrade straight away. But then there's this long tail of users that maybe they will never upgrade, right? Because those are the ones that are very slow to follow up on like version upgrades. So yeah, maybe we need to define a certain threshold below which we say at this point.
I guess like 14.0 would be like the moment when we remove unicorn.
Like a major release, right? Yeah.
And because like so far, I don't think that we really had any troubles with Puma. It's like it's running stable. So
yeah, I agree.
So I guess like it's kind of planning ahead.
It's also like we're already in a post-unicorn mindset, right? Because whatever we look at, we never even, I don't even think about unicorn anymore.
No,
right?
we don't even run unicorn anywhere.
Yeah, exactly. Yeah,
So
yeah.
There is no really reason like to think about unicorn anymore. It's like when we can get rid of that, basically.
Yeah, and then you also mentioned like there's like other stuff we're dragging around, right? The GitLab exporter that runs its own Puma server. Where like what maybe also next week we can look at these things and say what needs to happen so that we can actually toss this thing out.
Because like I think this like if we could remove that, this is also another like low-hanging fruit that you save 50 megabytes.
Yeah, totally.
From Omnibus, and like if we could remove that as well, it kind of keeps like very
absolutely.
Nice.
And you know, it's like another server that needs to be maintained. It's the memory use, but it adds configuration overhead and all these things as well. You know, that's just.
Hey, I think we discussed about a lot of different stuff. Let's note.
Good point.
Can you help me like what we discussed? Issue to remove unicorn.
Yes. I would say just add to this like unused or like components that are not used much, right? It's not just unicorn, right? It's also GitLab exporter. Yeah, and then, okay, well, maybe that's separate. We also want maybe to look at things that we don't want to remove, but maybe not run by default, right? That would be things like Grafana or like Prometheus. Maybe we don't need to run that by default. These are almost like product decisions because, because there's some convenience, of course, by running them by default. I can help you. Yeah, hang on.
What else we discussed?
I'm adding the gems discussion. Well, actually, that is kind of. Actually, maybe this is part of this. Actually.
Yeah, I wanted to ask that. Like, selectively load components should.
I'm just adding an example.
Probably.
Yeah, so I guess like the gem file has a concept of the group and like that you could really use in these cases. Interesting.
Okay. Yep. GraphQL and Grape as well. Oh, actually, I realized, should I share my screen so people watching the recording will actually see what we're doing? I'm going to share my screen again.
Yeah, that's a good point.
Yeah. Yeah. So we just added this. Yeah, it's just summarizing what's just been said. Okay. Should we quickly go through yesterday and today? You ready
Sure.
for that?
Yeah, why not?
Do you want to kick it off, Camille?
Just I answered one question. I look at this DDAP again, and I got the metrics wrong. Basically, I calculated it wrong. So actually, like what is to free in this default configuration is about like 2.2 or 3 megabytes. Like I created this very simple patch to Ruby VM that I tested. It actually freed 1.5 megabytes as part of
Did you posted the code? I'm interested in like what you did try. How
there
that
is a
test
link.
looks.
There is
Okay.
a link.
Okay, thank you.
It's pretty simple. Like it walks all heap pages, all slots, looks at the type of the reference, and like uses GC compaction, update references to rewrite these references to other objects, and then freeze these slots from other cases. So actually, this GC compaction like make it super simple to write, because the only need that I have to do is like to walk all pages to find strings to rewrite, recreate these strings using the frozen strings literal, which is like an internal structure of the Ruby that it holds all the duplicated strings in the hash table, and then like mark these slots as the free, so these slots would, I mean, these slots gonna be freed right away, basically. But then like you can run the GC compact again to actually compact the memory pages. So like this part is pretty simple. It's not bulletproof because like I didn't yet figure out in what cases you should use ASON poisoning, because there is like the concept of marking locations to read write. So it's not bulletproof, but I was able to run that basically on GitLab, and I was able to free a bunch of the objects, and I was able to run tests on that as well.
Cool.
Then I also like got curious like why I see so many unfrozen strings, and it turned out that I looked at the loaded files, and when I saw that we have 14,000 loaded Ruby files, I was kind of like screaming.
Yeah.
Ridiculous, because like this table of the files alone, the file names, it's 2 megabytes in the memory. Only the file names, basically, nothing else.
But is it something the Ruby VM maintains, or something we, like our app?
No, it's Ruby VM. It adds each loaded file into loaded features. They do that because subsequent require doesn't load the file again. Only like the load
Okay,
loads the
yeah,
file,
right.
but require only
Right.
load
Yeah.
if it's not loaded.
Yeah.
So you actually have like very good way to access exactly what was loaded, in what order, and things like that.
Loaded files, is that what you said?
Sorry, it's name loaded features.
Loaded features.
A global variable. But the one thing that I learned after analyzing these loaded features is like a number of the files doesn't use the frozen string literals, which is something that frozen literals makes the DDAP of the strings as part of the loading. So like in my section where I measure like these strings, like I have the frozen section and the unfrozen section. And unfrozen section pretty much came from the lack of the frozen string literals. And some of these are our gems, some of these are someone else's gems, but there is like a plenty of the gems that just doesn't use that. And it seems that like fixing that alone, frozen string literal should give us about 5 or 6 megabytes. I mean, adding frozen string literal to the header of the gem and fixing like these very few cases where it breaks. I'm not sure if you know like where it breaks and what is the impact of that. I can maybe show that quickly if you are interested.
Yeah,
Should
sure.
I stop sharing?
Mm-hmm. So like here we add frozen string literal. On top of that, on top of Ruby file, and what it effectively has, if you have the method that is like a string and it uses something like that, and you try to add some extra string or like modifying the string, it's gonna fail with the this first string being like not, you are not allowed to change this string because like this string, the way how it's like compiled by the Ruby compiler is frozen at that time. But if you have frozen string literal, which is false by default, this string is not frozen and you can modify that. So basically, we migrated GitLab code base to frozen string literal. And what we actually were doing is like adding plus, which means like duplicate the string or like unfreeze this string, which means like duplicate if it's frozen, which is like, and this is really like the only case where this frozen string literal true breaks. This is really like the fix for that. You only add plus in front, or like you add dup, which
Not
means
dup.
like
Yeah.
create
I want to ask is it the same? Yeah.
create mutable copy, basically, that you can modify. And what is really a nice upside of that is that this string, if you have these two methods that are basically have the same string, this string and this string, if it's frozen string literal, points to the same object. So it holds exactly the same slot in the memory. It's not, they are not separate strings, which is the case if this is written like that. If it's frozen string literal is false, if you get the object ID of that and that, they are different object IDs because they are mutable and they are kind of copied on assignment. But this makes it like to be actually more efficient because like you deprecate the strings across all loaded Ruby codes basically in the application. So if you have like million of the new line characters, it doesn't really matter then because it's always pointing to the same character. And I also got curious about like the symbols and strings literals being garbage collected. And it appears that if you use a symbol or a string, each of these objects, if it's no longer used or referenced, it's going to be garbage collected. So these frozen literals can also be garbage collected if they are no longer referenced. So it's pretty efficient from memory perspective, really, to do it in that way. Of course, it's like it doesn't. The frozen string literal doesn't cover all cases because there are still some strings that you can duplicate, but it's really like a very small portion of that.
So is the reason then that we have so many copies of like a new line and all this stuff, is that because they appeared as part of a string mutation or because they were in gems that we load that don't use frozen string literal?
They were in gems.
The second one. This is exactly what you're
but
saying.
how we fix that? Like,
just add to the header frozen string literal and fix this occurrence to use basically.
Could we override? Could we like override like patch require to always and like add this line before the file is required?
You don't really need to patch a line. You may pass Ruby opt parameter, but some gems just simply fail to load them because they are not fixed.
Yeah, it will break them.
And like, I can even show you, like if I do, I use Ruby opt. Let me check that. There is like the Ruby opt parameter for that you can force considering all files to use the frozen string literal.
Okay.
But okay, I actually have that. But then like some gems like HTTP kind 2.83, it's like it has exactly that case. If I look at this line in this, it's exactly this case that you need to add plus in front
Right.
to mutate this object. And it's kind of like easy fix, but like there is many gems like that needs to be fixed. But actually it gives a pretty nice memory saving, a few megabytes because of that.
But is there anything we can do about it?
Contribute to gems and fix them.
Yeah.
Which actually is beneficial. It's actually beneficial for the wider community as well, right?
That's true. Yeah.
True. Cool.
Okay.
Thanks for presentation.
So yes, and like we also talk about these. I look at the flame graph of the Puma startup, and when we finish execution of initializers, we are around 7,000 or 8,000 loaded files. But after the time, because of the roots, controllers, API, we still load 7,000 more files before we start processing requests.
Right.
It's kind of ridiculous, to be honest. And like this kind of, all of that kind of led me to the conclusion that we need to figure out to selectively load. Like there is no really way around the big one. That's it.
But with selective load, we need like to change a structure how the files are loaded, and we also need to change how the gems are loaded. So we need to manually load the files, and we need to check like how to bundle differently for Sidekick and Puma. So I really don't know where to start there. And also we need then to like run differently the initializers as well.
Yes, it's not easy task. It's probably like a major architectural change to the GitLab. But I think we are kind of like slowly getting to the scale that is inevitable because of the monolith and how much we are adding. So yes, like Nikolai, it will not happen overnight. It's probably, if we would have to execute that, it would be like the process that we will be slowly doing. Maybe initially proposing like the new pattern for all the new code. Maybe after some time fixing like the older code, but it would be like the process taking months.
Yeah, it sounds like an architecture blueprint thing, because I mean, you also need to bring all other developers on board with this, right? Because if people keep adding, sprinkling code around, maybe you want to even have some kind of tooling that, I don't know if it would be a cop, but there's this Shopify project called Packwerk, where they statically analyze your code and you can create domain boundaries based on rule sets, and then it will actually refuse to even build your code if you violate these boundaries. So I don't know, maybe this is something we can look at, but it's really hard to retrofit this on an existing big code base, right?
Yeah, because I wanted to like take a look how to like drop the GraphQL and then like where to start. Like it's not that you can just create simple POC by
I don't know, but maybe like for the GraphQL, like since you focus on like on the very specific component, like you prepare like the structure and like you migrate just this component initially, right?
Yeah.
And like because I would assume there is like gonna be a lot of challenges with that.
Yeah.
So like focusing on a single component could give like an objective really that we can see like how it plays with the wider architecture and like how it could be executed. So
yeah, and also this is a bit like simpler because GraphQL is a technical concern, right? So we actually know we only need that when serving API requests. But these domain specific boundaries, that's super tricky because that is something that is really hard to put in place after the fact. Things like, should you be allowed to, I don't know, make changes to whatever, like the issues domain when you're working on a controller that belongs to a different domain or something, like this stuff, that's mostly what Packwerk I think was designed for. Yeah, but that stuff was really hard to figure out. I also would say let's start focusing on the technical things that are a bit more obvious, like the syntax highlighting and the GraphQL,
exactly.
grape as well. There's a
exactly. So like there are like these components that that you don't really need in another context.
Exactly. Yeah.
Basically.
Yeah. Okay, I can go next. So basically, what I was trying to answer yesterday was where does this big discrepancy come from RSS used and what a lot of these memory reports will tell us we actually use on the Ruby heap. So there was a bunch of memory that it was not accounted for. So I was hoping I could drill into this and find by breaking down what does RSS even mean. So I actually spent some time. I posted these links to even read up on how all these different memory regions are defined. And there's this super useful tool called PMAP that will give you a breakdown of the memory areas. And I just threw that in this spreadsheet here where it's a bit easier to look at. But basically the PMAP output is on this left table here. And it will basically summarize by, I think that these are, I don't think these are pages. No, I think these, so size is basically the virtual memory, it's basically the memory request the process was making of this particular kind. That doesn't mean it's actually using that much memory, right? You can see it's like byte aligned and stuff. So the RSS column will actually say what was actually used here. So when the mapping column says blank here, it means it's anonymous memory. I don't know why. It should actually say something like anon. I don't know why it didn't do that here, but yeah. So this is all anonymous pages, so which are specific to this process. So they are, I believe, also not shared. And if there is a name here in the mapping file, then this means in the mapping column, it means it is file backed. So it was. Yeah, it's file back memory. So that's often like shared libraries and stuff. But yeah, the kind of disappointing takeaway was that it did not answer that question because like you can tell here. So this is now the sum. The blank thing is the sum of all the anonymous pages, which is almost everything, right? So it's a gigabyte of RSS, and then the rest. Yeah, here you can see the difference. So only. Well, it's like not, it's still a chunk. So it's, well, how much is that? So that minus that, which comes down to like 30 megabyte, maybe roundabout. So 30 megabyte are not in this big chunk of this big black box here. And that's this difference, the 30 megabytes is the sum of all these file backed memory maps, which, there's stuff in here like Ruby, and like a lot of them are really small, but some of them, so this is in kilobytes. So libcrypto is 2.3 megabyte. I don't know what we use that for. Like, I'm not totally sure, like for SSL or something, making outbound HTTPS requests or something. I don't know. 2.3 megabytes seems chunky though for a shared object, right? Yeah. But no like really big things with gRPC here as well, which might be difficult to get rid of. So I don't know. I didn't really have any major takeaways from this. Like, in terms of
I'm kind of thinking like, because maybe we compile all these libraries. Maybe it's also about tuning the compile options and like disabling the aspects that we are certain that we will never use as well.
Yeah. I mean, we could look at that for some. It's just like most of them, it's not even worth looking at. I mean, look at this is 48 kilobytes. Okay. I mean, like, I don't know if we look at every single one of them. It's just like the return on investment here seems low, right? Let's say we would cut this in half, then we have a megabyte saved, right? For where did it go for libcrypt, for instance, libcrypto. And then, by the way, here's the Ruby runtime, which is quite small. Like, it's only 3 megabyte. I was kind of surprised by that. I thought it was bigger, but yeah. Yeah, so that was that bit, and then after lunch we how do I actually go back when I'm in full screen? Right. So then later, yeah, we looked at like Igor. We had a sync call again, and Igor joined and paired a little bit on using JEProf, and yeah, Igor is amazing. Like he did an amazing job at like figuring out figuring out how to create the flame graphs. I kind of mostly like observe like what he was doing. But in the background, I looked a little bit at, basically what I looked at was this bit here. Hang on. Here, so we had others, yours actually, but I got similar results, like these reports of memory used by type. So we have 38 megabytes of hashes in memory. And I was just curious, like, let's just look at it, maybe something stands out. So I tried to, so I dumped, through object space, I just dumped all these hashes. That was way too big, like if you actually dump the full hash. So I ended up dumping just the by keys. So I took the key set and then the size the hash consumed. And the key set, I was hoping kind of giving away what we're dealing with here, what this might be. So the summary is down here if you want to look at it. So there's some like okay, so ignore always ignore these entries here because that is the script itself, because it also creates hashes. But like anything outside of like this line, for instance, this means here we have almost 80,000 empty hashes in memory. So it has an empty key set, right? And the size of memory, this is the occurrences. So we have 78,000 empty hashes, and then we also summed them up because some of them, the empty hash should always be the same size, but so this is 3.2 megabyte of empty hashes. By the way, this particular one, I think this might get a lot better. My suspicion is you can't see like where these come from here, but my suspicion is these might all be default hashes, and the way the Ruby VM handles the default what is it called? These like named the named parameters, right? If you have like named defaults, right, for a method.
So like Matthias, isn't like the same problem as with like a string? It's like it seems like the same pattern. Like you have the code, in the code you have like empty hash like being used.
It could be, yeah, it could be.
And basically this kind of translates to this structure. You then like it gets copied as an object. I think it's basically the same problem as with a string that we had, right?
It might be. So what I was thinking about,
they solved that with the frozen string literal.
Okay, so what I was thinking about was methods like these, I believe, where you have something like that, where well, actually, so sorry, these don't have default values. I think you would have to have something like default values. Like this method can be called like this, right? Oh my God. I can just say, I can call this method without arguments because they have default values. And internally, the way Ruby VM implemented this prior to 2.7 was quite inefficient because it always created a default empty hash to represent these default arguments. And that has changed with 2.7 to be more efficient. But we're not making use of that because we still often default these like options to like explicitly use empty hashes. And there was even a warning, like remember when Stan did the 2.7 upgrade, he had to silence like 15,000 warnings or so because there was this warning saying you shouldn't be doing that anymore because the Ruby VM takes care of that. So I think that at least to a good portion that's included in this. But yeah, you're right. It might also be just something like yeah, I don't know, you start out with an empty hash and no, but then it should be garbage collected, right? So
I guess like but like in the VM you still need to have this defined as an object that you may copy. In that raw form, it's basically probably the same problem as with a string. I'm thinking. So yeah. Like the empty hash, empty array, where you have like predefined parameters, they are not did up at all. No, they are not copied. So I'm kind of like thinking that maybe, can I share my screen for a second?
Yeah. Let me just a few more. If you look at this, there's a couple interesting things where I think, I don't know if this is from the Ruby VM or if it's like some kind of meta programming we're doing, because there's clearly stuff going on where we keep hash presentations or something that sounds like a proc or a method. So maybe that's just a Ruby VM, but it's quite sizable as well. Like, I mean, look at this. This is 2 megabyte, 1.5 megabyte. And then something related to like character code pages or something like that. I don't know what this is. Like maybe someone, yeah, who's been around the code base more might be able to identify this. You know, again, 1.6 megabytes, it all adds up, you know, like if you add up all these things here, you come down easily to 10 megabytes of stuff that we might be able to, yeah, maybe not get rid of, but reduce in size. Okay, hang on, I'm gonna stop sharing. There you go.
So I'm thinking that like, I'm even looking at the Ruby code. I'm just wondering, like, this very likely is a new hash object, right? This very likely is a hash object that is like allocated in that form.
Right. Yes.
This very likely is the same, and like probably.
But this should be garbage collected, right? If you mutate, well, if you either you mutate it and then it's still in use and it's not empty anymore, so it wouldn't show up in that report, or it's like, oh, you make a copy and the empty object is not being garbage collected for some reason. That's why.
Yes, but like you need to have this source that is as part of the compile that is written like that. Like you need to have this source form that that Ruby VM can then like mutate to allow you to give you like a very specific instance that is gonna be then garbage collected. But this is very likely a different hash than this in the as an active slot.
Yeah,
so
it will be. But I'm saying this one is not going to show up in the report I pulled because I did a major GC after that. So these 3.2 megabyte of empty hashes have inbound references so that they're not eligible for garbage collection. So they must be sitting somewhere being held onto. And what you return there is just a temporary value. It will be garbage collected.
I'm just curious, like how it looks from the Ruby VM. Compile, because this is really like the most interesting. Like if you have something like that, it's actually doing new hash, but the question is like where it is taking this object from.
Oh, are you thinking it's maybe using like reusing a shared instance because it's empty, kind of like a null object?
Okay, so actually for this one it uses a new hash, but for like case like that, it uses dup hash, actually it duplicates a hash. So like for this one, it actually has the optimization, so it's not that. But for the hash that is like more complex, it just stores the base in the memory, in a completely not the duplicated form, and it duplicates this hash basically that is stored somewhere else in the memory. So it's interesting basically how many hashes you have that are referenced by the ISIC.
So which hash is it duplicating though? Is it duplicating the empty hash and then it's mutating a copy so that it inserts these elements?
No, yeah, I think what is happening, like if it sees something like that, it's creating new hash. But if it sees the hash that has value, it needs to store this hash somewhere and it's doing duplicate hash. And the same seems to be to the empty array. It's using new array. But for an array like with some values, it's actually doing duplicate of this array that is stored somewhere as part of the compilation. It's actually interesting, like to see how because this is efficient, like in this form, what it appears. What is not super efficient if you have like in two different methods something like that, even though they are basically the same, they're gonna be stored like as two different hashes.
Yeah, for sure. Yeah. Yep. Okay.
Can I go next?
Yeah, please go ahead. Can you share your screen as well with the
Yeah, I don't have much to show, but let me share the document. So yeah, yesterday I paired with Alexei. We ran Puma in the single mode and tried to run GPT to like warm up the instance and then taking a heap snapshot again. And we tried to look that snapshot using hippie to like maybe figure it out something, because previously we were concentrating on like taking snapshots during the boot time. So I was hoping to see something interesting when the application is running and under the heavy load, but there are a lot of data there and nothing like stands out. Like there are some files like metric instrumentation that is appearing like with a big number of allocation, and we already know that like UCaml tried that it doesn't save us much space. So I'm not really sure like what to do with all of that data. And we also looked at the CA jobs that like are running derailed benchmarks on our production. Unfortunately, we are not running the memory profiler there. So maybe this is something that we maybe can add for the future, because I guess that like memory profiler report can give us more information, because at the moment we are just getting the summarized memory consumption of the requested files, and that's it. So maybe running also this memory profiler benchmark would give us better insight what's happening in production, because it contains retained and allocated memory by file, by class, and everything else. I was able to run that derailed benchmark on my local environment, but I cannot run it on virtual machine instance. I couldn't make it work. And the third one is what Matthias said. We like Igor joined, and we were able finally to like run the actual gprof against this gmalloc dump. Because yesterday we were able to like create a dump, but it didn't like fix the addresses. It was just showing the addresses in the memory. It didn't contain any useful info. So this time we fixed it, and Igor even created a nice flame graph SVG from it. So it was great exercise, but those are a lot of low level stuff, and this SVG is huge and it's slow. So I couldn't like get any useful info from it yet, and I'm not sure that I will pursue looking at it, because we have a lot of information collected, and maybe we should just start looking at something more smaller.
actually, like it's funny. Igor just posted a smaller version of that
Awesome.
SVG, which uses a min, like a cutoff for the sample size. I think it is, so that it should be. It's only it's like 30 times smaller. So that sounds promising. It should be a bit easier to look at.
Yeah, it's interesting really to see what's going on, but yeah.
I mean, if I read it correctly, it looked like the largest chunk was allocated from requires, right? Kernel load, which makes sense. But it doesn't tell us much, you know, it's just basically telling us the same thing we already knew, is that we're loading a lot of code. Yeah. I mean, there were other like smaller regions that might be interesting to drill into. I mean, it's just like the SVG is not interactive, right? I mean, most of the flame graph visualizers I had used, I can drill into these things, right? So the SVG does not allow me to do that. So that's also a bit like a limitation. I don't know if there's like another way to view that interactively so that you can actually you know what I mean? Like actually expand
Yeah,
on these
yeah,
individual flames
yes.
and go down the subtrace. That would be useful.
It would. It would. Okay, so I'm not sure. Maybe today I will concentrate on like removing some gems and maybe reading and finding a way how we can selectively load something. Because I don't know, yesterday like was the second day we collected a lot of data and looked at it, and I feel like powerless. Like I don't know what to do with the data. Like I couldn't conclude anything from it. Yes, we found there are a lot of strings, and we found that we load a lot of data, a lot of stuff, and but not, as you said, nothing big stands out, which is expected. Like we were not hunting some big memory leak. Like we need to optimize smaller. So I agree with Camille that maybe selectively loading stuff is the next big major thing that we should do.
Nicola, I'm kind of wondering, maybe there is like some very easy way or like very low hanging fruit way for us to try out. If we would remove GraphQL completely, how much the side key memory would change?
Sure, like the gem consumes.
Like you remove the gem, you remove all the code, and you just kind of look at the this heap analysis, maybe like this count. I mean size objects that I did, maybe also RSS, and like because it could give us like some hint exactly how much saving we may be looking at.
I agree. I can try that today. That makes sense.
And maybe like doing the same, like remove the full controllers folder and try to load.
And grape.
And remove full API folder and try to load.
Yeah. So grape, GraphQL, and controllers. Got it.
I mean, like in steps, right? Not at the same time.
Sure. I can do that.
So I guess that's it for today, right? We're gonna basically kind of wrap up on Monday memory meeting, all of that.
Cool.
I guess good luck and happy weekend after good luck.
Yes. Same. Thanks. Thanks, guys.
Thanks.
Have a nice day.
Bye-bye, you too.